In section 2.6, we're going to start talking about even more geometric proofs. Now, the examples on these pages we actually did in our video of proofs a few weeks ago, but we're going to add a few more theorems to what we're doing. Now, to review, a theorem is any statement that you can prove. Once you have proven a theorem, you can use it as a reason in later proofs. So we're going to go over some theorems. The first one is Theorem 261. It's called the linear pair theorem. It says that if two angles form a linear pair, then they are supplementary. So right here, angle A and B form a linear pair, therefore they are supplementary. Theorem 262 is called the congruent supplements theorem. It says that if two angles are supplementary to the same angle, or to two congruent angles, then the two angles are congruent. So let's look at this. Here's what it says. If we have angle 1 and angle 2 which are supplementary, and angle 2 and angle 3 are supplementary, then angle 1 is congruent to angle 3. Congruent supplements theorem. If angle 1 and 2 are supplementary, and 2 or 3 are supplementary, then 1 is congruent to 3. Now, the next thing we're going to cover is kind of how you plan out your proof. Before you start writing a proof, you should plan out your logic. Sometimes you will be given a plan for a more challenging proof. This plan will detail the major steps of the proof for you. So here are two more theorems to add to your bank of reasons. Right Angle Congruence Theorem. It says that all right angles are congruent. So, here's the great news. If we know that two angles are right angles, we know that they're congruent. So you can say, if you are given in a problem, this angle and this angle are right angles, you can just say angle A as your statement. Angle A is congruent to angle B. Why? Because of the right angle congruence theorem. Congruent complement theorem. It says if two angles are complementary to the same angle, then the two angles are congruent. It's just like what we said about the supplement angles theorem, or the congruent supplements theorem, but this is talking about complementary angles. So it says if angle 1 and angle 2 are complementary, and angle 2 and angle 3 are complementary, then angle 1 is congruent to angle 3. Here's our first example. We're going to write a two-column proof from this information. It says use the given plan to write a two-column proof of the right angle congruence theorem. So we're actually proving the right angle congruence theorem. Here's our given. Angle 1 and angle 2 are right angles. I want to prove that they're congruent to each other. Now, once again, what we are doing, we are proving Theorem 263. So this is what we're talking about a theorem. If we can prove a theorem true, then we no longer have to prove it true. We can just use that theorem as our reason. So right now we are proving the Theorem 263 that we just went over. So let's do our statements and our reasons. So 1, angle 1 and angle 2 are right angles. And our reason would be because they are given. So the statement 2, what could we say? Because we know they're right angles, what do we know about them? We would know that the measure of angle 1 is equal to 90 degrees and the measure of angle 2 is equal to 90 degrees. How do we know that? Because of the definition of right angles. The definition of right angles says that if an angle is a right angle, it's 90 degrees. Now, example number 3, or statement 3. We can say that the measure of angle 1 is equal to the measure of angle 2. Here's why. If the measure of angle 1 is 90, and the measure of angle 2 is 90, then we can say the measure of angle 1 is equal to the measure of angle 2. Why? Why do you think that is? because of the transitive property of equality. Now we can say that angle 1 is congruent to angle 2. And why is that? Because of the definition of congruent angles. So remember, normally what do? We always name things congruent first, and then we say they're equal by using definition of congruent, either segments or angles. Because the definition of congruent angles, we can go from congruency to equality. We can also go from equality to congruency for the same reason, which is the definition of congruent angles. Now, if it helps you, here's your proof process. Write the conjecture to be proven. Figure out what you're trying to find. Draw a diagram to represent the hypothesis. State the given information and mark it on the diagram. That's great information. Whatever you're given, you mark it on your diagram. Then state the conclusion of the conjecture in terms of the diagram. So kind of figure out where you need to go with your conclusion. What do you need to prove? And then plan your argument and prove the conjecture. Let's try another example. Angle 2 is congruent to angle 3. There's our given. Notice that it's already been marked in our picture. We want to prove that angle 1 and angle 3 are supplementary. So let's first make our proof outline. So I've already put down the given, which is that angle 2 is congruent to angle 3. So let's try to think of a plan. Angle 2 is congruent to angle 3. We have to prove that angle 1 and angle 3 are supplementary. So let's think about 1 and 2. What do we know about 1 and 2? They're also supplementary. So let's go from there. Now when we're talking about supplementary, we know that the measures of angles have to add up to 180. But currently right now we don't have the measure of anything. We have congruency. So we're going to first start with what? If we know angle 2 and angle 3 are congruent, what do we know about them? We know that their measures are equal. So then we can say that the measure of angle 2 is equal to the measure of angle 3 because of definition of congruent angles. Statement 3. Where do you think we can go from there? The measure of angle 2 and the measure of angle 3 are congruent. So let's think what we can say. What do we know about 1 and 2? We know what about 1 and 2? We know that angle 1 and angle 2 are supplementary. And here's why. In your bank of reasons, you just added definition of a linear pair. Or linear pair theorem. The linear pair theorem, remember what it states. The linear pair theorem states that if you have two angles that form a linear pair, we know they're supplementary. So we can say angle 1 and angle 2 are supplementary because of the linear pair theorem. We know they're the linear pair because a linear pair means they make a straight line. So if we know that they are supplementary, what do we know about them? Because we still haven't proven it. If we know that they're supplementary, that means their measures what? Their measures will add up to give you 180 degrees. And how do we know that? Because we just said they're supplementary, and supplementary angles add up to 180. Now we also know what? We now have just said that 1 and 2 are supplementary. So let's look at what we have here. The measure of angle 2 equals the measure of angle 3. The measure of angle 2 equals the measure of angle 3. I want 1 and 3 put together. I currently have 1 and 2 put together. But the angle 2 is equal to angle 3. So It's like, remember like when you did substitution with linear equations or a system of equations? If you had y equals x plus 5, you took it and plugged it in for y. We are saying that the measure of angle 2 equals the measure of angle 3, so we're going to substitute it in. So we can then say the measure of angle 1 plus the measure of angle 3 equals 180. Why? Because of substitution. The measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. So our final step, we just said that they're 180. We're going to work backwards. Look at what we just did. We said something supplementary, therefore we say it can be equal to 180. But now we said something is equal to 180, we can now go backwards and say that angle 1 and angle 3 are supplementary. And why? Because we know, by definition of supplementary angles, the angles that add up to 180 are supplementary. The only vocab word we went over in this section is theorem.